Now we're going to discuss few important results which helps you to solve any kind of problems. First one is the sine of a plus b into sine of a minus b is equal to sine square a minus sine square b or cos square b minus cos square a. You could get a doubt how this one equation, how this one multiplication can be equal to two different values. It's actually when you get the result, when you either do this way or this way, the product or the final result you will get as same. Let's see how it is. Let's derive this. So first, this is the LHS, right? So let's take the LHS. That is sine of a plus b into sine of a minus b. I hope you all know the formulas, right? Sine of a plus b is nothing but sine a cos b plus cos a sin b. Similarly, if you write it for sine of a minus b, everything gonna be same as it is. Here, just minus comes. Okay. Now let's substitute this. It becomes sine of sin a cos b plus cos a sin b into sin a cos b minus cos a sin b. So when you multiply it, okay, you will get it as sin square a cos square b, and you multiply this value with this value. And when you multiply this and this, the first and the fourth one, and the second and third one, when you multiply, these values get cancelled. So the remaining value is cos square a sin square b. Here, there are two chances. The first chance is either you can write cos in terms of sine, or you can write sine in terms of cos. Okay. Similarly, it happens with cos square b or sin square b, which is nothing but 1 minus cos square b, using the basic identity. So here you will have two chances. That's the reason this product is equal to two things. So now let's write cos in terms of sine. It becomes sine square a. Cos square b is nothing but 1 minus sine square b minus cos in terms of sine, that is 1 minus sine square a into sine square b. So this is one thing. And the other thing is, I told you, now change sine in terms of cos. It becomes 1 minus cos square a, and this cos remain as it is because it's already in cos. Sorry, here it will be minus. Cos remain as it is. Just change this sine to cos. Now, here when you multiply it, it becomes sine square a minus sine square a sine square b. Similarly here, minus sine square b, minus into minus plus sine square a sine square b. So these two values get cancelled. The final answer will be sine square a minus sine square b. This is one of the RHS part. Similarly, do the multiplication over here. It becomes cos square a cos square b and minus cos square a minus into minus plus cos square a into cos square b. Again, these two values get cancelled. The final product or the final RHS will be cos square b minus cos square a. So this makes the one of the RHS part. So that is the reason when you multiply, or when you do the product of sine of a plus b into sine of a minus b, you will get two values, or it can be written in terms of sine and cos, which is nothing but sine square a minus sine square b, or cos square b minus cos square a. So this is the required RHS to this LHS part. So let's solve few questions so that you'll get an idea how and where to use this kind of results. In this question, we need to solve this equation. Solve in the sense we need to find the general solution for this equation. So if you observe, it is sine square 3x plus sine square 5x is equal to sine square 2x plus sine square 4x. We need to use this formula. So we need to make the equation in such a way that is sine square 3x minus sine square 2x plus sine square 5x minus sine square 4x will be 0. Now it's in the format of sine square a minus sine square b. So you can use this formula. By using that, it becomes sine of a plus b. 3 plus 2, 5x into sine of a minus b, that is sine 3 minus 2, which is 1x, plus 5 plus 4, it becomes sine of 9x. 5 minus 4, it's again 1, so sine x will be 0. From this 2, you can take sine x common. So it will be sine 5x plus sine 9x is equal to 0. Now, if you observe over here, it's in the form of sine c plus sine d. So what's the formula for sine c plus sine d? It is nothing but 2 times of sine c plus d by 2 into cos c minus d by 2. From here, we can write it as sin x remain as it is 2 times of 9 plus 5, which is 14 by 2, 7. Sin 7x cos 4 by 2, which is 2x. If you observe over here, the basic property of cos is applied, which is cos of minus theta is equal to cos theta. So here cos of minus 2x is written as cos 2x. And from here we can write this equation as 2 times of sin x into sin 7x into cos 2x is equal to 0. From here we'll get three possible cases, that is case 1 in which sin x is 0, case 2 in which sin 7x might be 0, and case 3 is cos 2x might be 0. So if you observe the case 1, it is in the form of sin theta equal to 0, which is a simple t equation. So the general solution will be x is equal to n pi, where n belongs to all the integers. Similarly, this also, case 2, it's in the same format. So here 7x will be n pi and x becomes n pi by 7 and n belongs to all the integers. Here it's in the form of cos theta equal to 0. So the general solution for this will be 2x is equal to 2n plus 1 times of pi by 2, and x can be written as 2n plus 1 times of pi by 4, where n belongs to all the integers. So these are the three general solutions for the required question. The second important result is cos of a plus b into cos of a minus b, which is equal to cos square a minus sin square b, or cos square b minus sin square a. If you remember the RHS part of the first result, in which both the terms are either sine or cos. But here it is cos square some angle minus sine square some other angle. Right? But here the angles can differ but the final answer gonna remain same. If you differ the angle also, the final answer gonna remain the same. So here it can be first either A, next B, or first cos square B minus sin square A. So let's derive this. So first let's take the LHS part, which is nothing but cos of A plus B into cos of A minus B. I hope you all know the formulas, right? The basic one, which is nothing but cos of A plus B. What it is? Cos A, cos B. Minus will come because inside it is plus. And this is only applicable for cos. Sin A, sin B. Similarly, for cos of A minus B, it will be, this part will be same. And instead of minus, it becomes plus. And this part is also same. So just substitute these values over here. It becomes cos A, cos B minus sin A, sin B into cos A, cos B plus sin A, sin B. So just multiply it. You will get it as cos square A, cos square B. When you multiply this first and with this third one, and these two get cancelled, and the remaining thing is minus sin square A into sin square B. Again, you have two possibilities. That is either convert whole equation in terms of cos or convert whole equation in terms of sine. That can be written as cos square A can be written as 1 minus sine square A, or sine square A can be written as 1 minus cos square A. Similarly, it goes with B. That is cos square B is nothing but 1 minus sine square B, or sine square B can be written as 1 minus cos square B. So just substitute these values. First, let us convert whole thing in terms of cos. It becomes cos square A, cos square B minus 1 times of cos square A into 1 minus cos square B. The other possible thing is either convert cos in terms of sine. It becomes 1 minus sine square A into 1 minus sine square B minus sine square A into sine square B. Now, first, let's do this. This will be as it is. Just multiply over here. It becomes 1 minus cos square A minus cos square B plus cos square A into cos square B. So when you multiply this minus sign with the whole thing, this cos square A, cos square B, and this will get cancelled. So the remaining part will be minus 1 plus cos square A and plus cos square B. Now this can be written as cos square A plus, if you combine these both, take minus out common, you'll remain with 1 minus cos square B. 1 minus cos square B is nothing but sin square B. So it will be cos square A minus sin square B. Okay, this is one of the RHS part. So if you do here, it becomes 1 minus sin square A minus sin square B plus sin square A sin square B and minus sin square A sin square B. These two values gets cancelled. The remaining thing is, if you take 1 minus sin square B and minus sin square A, you'll get it as 1 minus sin square B is nothing but cos square B minus sin square A. Okay. If not, from here itself you can derive the other thing. Like if you combine 1 minus sin square A and write sin square B as it is, you'll get it as cos square A minus sin square B, which is nothing but this value. Okay. From here also you can derive it, but you can derive it from here also. Similarly, from here, if you take instead of cos square A over here, if you take cos square B and combine 1 and cos square A, you will get this value again. So basically, you will get both the parts of RHS from one single part. So this is one of the RHS and this is one of the RHS, and these will get when we multiply cos of A plus B into cos of A minus B. So this is also an important result to remember, because these kind of easy shortcuts or tips or the results helps you to solve problem quicker. In this question, we need to solve this trigonometric equation. Solve in the sense we need to find the general solution of this equation. So the first step, it's gonna be transfer this 2 on the LHS part and distribute it like cos square x minus 1 plus cos square 2x minus 1, and write other two values as it is. And now you could get a doubt. Why should we distribute this 2 only to the first two values, not for the first, second 3, not for the second 2 or first 3, like in any order what we want? So for this, the answer will be you need to have a lots and lots of practice. And second, when you do the next 2, 3 steps in your mind, like just calculate it, you should get an easier solution. Matlab, you should get a solution in an easier way. So only that will be possible only when you distribute that 2 for the first two values or the first two smaller values. So now it's gonna be minus sine square x according to the basic identity, and here also it becomes minus sine square 2x. Write the remaining values as it is. Plus cos square 4x is equal to 0. You need to combine one cos with one sine. But what to combine here? There are two possible cases. Either we can combine this sine with this cos or with this cos. And similarly, this sine can be combined with either this cos or this cos. But if you think in mind the next two steps of this, it will be easier if you combine this sine with this cos and combine this sine with this cos. Why so? Let's see the next steps. You will get an idea. So now it becomes cos square 3x minus sine square x. I'm just combining the values, okay? Plus cos square 4x minus sine square 2x. This is equal to 0. Now use this formula and you can write it as, now according to the formula, this becomes cos square A minus sine square B. So this is A, this is B. Now this can be written as cos of A plus B. So it becomes cos of A plus B is 3x plus x is 4x into cos of A minus B. 3x minus x is cos 2x. Similarly, when you assume this value as A and this value as B, we can write it as cos of 4 plus 2, 6x into cos of 4 minus 2, 2x is equal to 0. From this, you can take one thing common, that is cos 2x, and inside it's gonna be cos 4x plus cos 6x is equal to 0. So if you remember a formula, which is cos C plus cos D, what's the formula for this? It's nothing but 2 cos c plus d by 2 into cos c minus d by 2. Just use this formula and you can write it as cos 2x remain as it is. Inside it becomes 2. C plus d is 6 plus 4, 10. 10 by 2 is 5. Cos 5x and 4 minus 6 is minus 2 by 2 is minus x. But you know, right, cos of minus theta is cos theta. So here it can be written as cos x is equal to 0. From here it becomes 2 times of cos x, cos 2x, cos 5x as 0. Now we have three different cases. So one will be case 1 in which cos x might be 0. For this, what is the general solution we can write? What is the general solution of cos theta equal to 0? The general solution is x is nothing but 2n plus 1 times of pi by 2, where n belongs to all the integers. So similarly, case 2 is cos 2x is 0. Again, use the same general solution logic, that is x will be, sorry, 2x will be 2n plus 1 times of pi by 2, and from here x will be 2n plus 1 times of pi by 4, where n belongs to all the integers. Next, case 3, which is cos 5x is equal to 0. Again, use the same general solution formula, that is 5x will be 2n plus 1 times of pi by 2. From here, x can be written as 2n plus 1 times of pi by 10, where n belongs to all the integers. So basically, these are the three general solutions for this question. In this question, we need to find the sum of solutions of the equation which is given in the range is also given. Okay. So first solve this equation. Let's first find the general solution of the equation. So if you observe over here, this is in the form of cos a plus b. So this is nothing but a, this is b into cos of a minus b. So you can use this formula. So now it can be written as 8 cos x as it is, cos of a plus b into cos of a minus b. This can be written as cos square a minus sine square b. You can use any one of these, but I'm using the first one. So cos square pi by 6 minus sine square x and minus half remain as it is equal to 1. So now it becomes 8 cos square, sorry, 8 cos x as it is, cos square pi by 6, which is nothing but 1 by 2 whole square is 1 by 4 minus sine square x minus 1 by 2 is equal to 1. Simplify it, you will get it as 8 cos x. 1 by 4 minus 1 by 2 is nothing but 1 by 4 minus sine square x is equal to 1. So from here you will get it as 8 cos x into 1 minus 4 sine square x by 4 equal to 1. Now just multiply the cos x with the inside value, remain 2 as it is. Why? Let's see the next step. Because it becomes cos x minus 4 sine square x cos x is equal to 1. Write the sine square x in terms of cos. It becomes 2 into cos x minus 4, 1 minus cos square x into cos x equal to 1. Now, when you simplify this brackets part, you will get it as 4 cos cube x minus 3 cos x equal to 1. If you remember cos 3x formula, what it is, cos 3x is nothing but 4 cos cube x minus 3 cos x. So now you can put cos 3x instead of this, which becomes cos 3x is equal to half. I'm sending this to on the RHS part, which is nothing but cos of pi by 6. Now this is in the format of cos theta equal to cos alpha. So the general solution will be 3x is equal to 2n pi plus or minus alpha. Alpha is nothing but pi by 6. So from here, x will be 2n pi by 3 plus or minus pi by 9. But it was told that all this, but it was asked to find out this sum of solution in the range of only 0 and pi. So first, let's put n equal to 0. It becomes x is equal to pi by 9 because we should not consider minus value because range is only 0 comma pi. So next, if you put n equal to 1, x will be 2 pi by 3. If you keep plus pi by 9, it becomes 3 to 6, 7 pi by 9. So which lies in the range. And if you take minus, that is 2 pi by 3 minus pi by 9, it becomes 5 pi by 9. This also lies in the range. But when you take n equal to 2, it becomes 4 pi plus pi by 9, which exceeds the range, right? So the sum of the solution will be pi by 9 plus 7 pi by 9 plus 5 pi by 9. So the final answer will be, so the final sum will be pi by 9 plus 7 pi by 9 plus 5 pi by 9, which is nothing but 13 pi by 9 is the correct answer to this question.